A 3 kilogram mass moving with a speed of 2 meter per second is closing on a 2 kilogram mass moving with a speed of 1 meter per second. The masses collide and stick together. What is the speed of the combined masses after the collision? What impulses is experienced by the 3 kilogram mass during the collision? So this is 3 kilogram mass, and this is 2 kilogram mass. This is collide and stick together. This means this collision is elastic collision. This collision is perfectly elastic. Momentum is conserved and so the final velocity is 1.06 meter per second. An object traveling at 10 meters per second undergoes an acceleration of 4 meters per second while moving a distance of 100 meters. Determine the final velocity of the car. So the velocity is 10 meters per second and the acceleration is 4 meters per second and distance is 100 meters. We are going to apply this to the equation that you can find this, then the final velocity is gonna be 30 meters per second. A ball is thrown horizontally from the top of a 20-meter tall platform. The ball travels 4 meters horizontally before striking the ground. Determine the initial velocity of the ball. So we are going to throw this ball horizontally. This is gonna be falling down to the ground. And this height is 20 meters. And this is 40 meters. So the distance to the x-axis is this 40 meters and height is 20 meters. And we are going to find these. And this is mean the velocity and time. This is in terms of x-axis and this is in terms of y-axis. So we are going to apply this to this. So So the velocity is 20 meters per second. A 2 kilogram mass and a 1 kilogram mass are connected by a string. The masses are pulled along a horizontal surface by a 12 Newton. What is the acceleration of the 2 kilogram mass? Determine the magnitude of the tension in the string. So this is 2 kilogram mass and this is 1 kilogram mass, and they are connected by a string. And the force is gonna be 12 Newton. So this is gonna be 12 Newton. And this is 3. So the acceleration is gonna be 4 meters per second. About the magnitude of tension of in the spring, force is so 8 Newton is the answer. An 8 kilogram mass is attached to a vertical string. The mass is lowered 0.50 meter to equilibrium, where it remains at rest. Determine the spring constant. How much work is done on the spring to stretch it 0.50 meter? So the mass is gonna be 8 kilogram, and this distance is 0.5 meter. So this is gonna be work. And this is how we can find the potential energy of spring. And the work is 20 joule. And the force of spring is 80 Newton, and so 160 Newton per meter is the answer. A masses are connected by a string which is strapped over a pulley. The masses are released from rest. Determine the magnitude of the acceleration of mass m. The force of system is gonna be this. So the acceleration is gonna be 2.5 meter per second. Describe the friction force if the releasing motion is constant velocity. Describe the force. So we are going to describe the force, and the force to the x-axis is this, and this is equal to friction force, and the force to the y-axis is gonna be this, and this is and we can find the normal force by using this. And the friction force is gonna be this. This, and this. The loop has a radius of 10 meters and the velocity at the top of the loop is 10 meters per second. What is the apparent weight of a 50 kilogram passenger riding in a roller coaster car? Apparent weight is a measure of the normal force acting on a mass. The centripetal force is the sum of the two forces acting on the passenger in the car. So the centripetal force is gonna be this. So the normal force is 0. In this case, the passengers would feel weightless at the instant the roller coaster reaches the top of the loop. An object is lifted at constant velocity by a force to a height. To accomplish this in time, power is required. In order to lift the object to the same height in half the time, what force and what power are needed? So both times the object is lifted to the same height at constant velocity. To overcome gravity and move the overcome at constant speed, the upward force must be equal to the force of gravity. Therefore, each time the needed force is the same regardless of time during which the force acts. Moving the object the same vertical distance h requires the same amount of work against the force of gravity. However, in order to do this in half the amount of time, twice the power is needed. So the twice the power is needed. So this is gonna be the answer. Three forces act on as shown. Determine the magnitude of force so that the resultant force acting on the mass is zero. So this is 5 Newton, and this is 4 Newton. Yes, this is omitted. And so we are moving this to this way for making triangle. Then this is gonna be 3 Newton according to Pythagoras theorem. So according to Pythagoras theorem, the force is 3 Newton in the x direction.